Hi everyone. So welcome to another lecture of Corporate Sustainability Accounting lecture series. Today we are going to talk about another aspect, another element of environmental management accounting, which is accounting for water, environmental management accounting tools and techniques for water. So, up to now, you have discussed different dimensions, right? Like accounting for waste, accounting for energy, accounting for carbon footprint, accounting for climate change, accounting for material, accounting for biodiversity, and then today you are going to talk about accounting for water. So water is a very precious thing, right? That I don't have to explain that. So in organizations also, organizations, every organization in this world need water. So how can we keep accounting for this water consumption and water discharge and water withdrawal? Those are the three main things, right? So that is the first focus actually, accounting for water. And then we are going to talk about other EMA tools in the next recording. Right. So going forward, so as I mentioned earlier, still we are in module number 2, environmental management accounting. So this is the last accounting type, accounting for water is the last segment of EMA. And these are the learning outcomes as well. Right. So EMA techniques and tools under this, we are going to talk about accounting for water. So as I mentioned earlier, this is the focus of this recording. And later on, we are going to talk about other EMA techniques, accounting for water. Right. Now, before talking about this, how to keep accounting for water consumption and all, there are two main approaches of water management. Water management is also a very important thing. So as you can see, behavioral aspects as well as engineering aspects, we say. What do you mean by behavioral aspects? It involves efforts to utilize HR to bring about the changes in water use. Basically, when you have to manage the water of an organization, you can use the employees, human resources in an organization, and we can do behavioral changes. One example would be if the water taps are not closed properly, we can change the behavior of employees of this organization. See a tap is leaking, that tap is not closed properly, then they tend to go and close the tap properly. And then after every use of the water tap, employees, their behavior is to close the tap properly and not to waste water unnecessarily. Likewise, we can change the behavior by changing the behavior of employees, we can manage the water. That is one aspect. Another aspect would be engineering aspect, involves changes in physical capital directed at preserving water. Look at the first photograph. It is like we are changing the behavior of employees to close the taps properly. Second one is it's an example for a maybe sensor tap. So it involves capital investments. It involves technology. So maybe using technology, capital investments, organizations can manage water, like introducing sensor taps instead of using traditional taps where we have to open and close. Sensor taps would be there, minimizing the water wastage. So those are engineering aspects. So these are the two methods, two approaches we can use for water management. Now in an organization, both these methods, both these approaches can be used, behavioral aspects as well as engineering aspects. Right. Sorry about it. Okay. Now, apart from this behavioral and engineering aspects, there are several wastewater purification methods. Now, in this lesson, we are going to talk about three wastewater purification methods: solid, liquid separation. We are separating solids from the liquid. That is actually physical purification. Physically, we are purifying. Second method is biological purification. biological cycles. And then the third one is chemical purification. So we'll see what do you mean by solid liquid separation. Solid liquid separation, basically we are separating solid items from wastewater. That is the main thing we are doing. Under this, we can use different methods: sedimentation, filtration, and oil and grease removal. What do you mean by sedimentation? Sedimentation is removal of particles from wastewater that is anyway happening. Sedimentation, I will show you some simple example. If you take a coffee, if you take a coffee cup, when you keep, after making the coffee, when you keep that coffee cup on the table for few minutes, what happens? That coffee, that remainings get sedimented at the bottom of the cup. Sedimentation. So as you can see the sediments here. See, this is coffee sediments. So at the end, after a few minutes, when you keep the cup still, when you are not using the spoon, sediments are getting to the bottom of the cup. And then at the end of after drinking the coffee, we can see the sediment. This is sedimentation. So when you do this in large scale, it is like if we can fill the wastewater or the water into a big tank, right? With big tank, we can keep the water, right? We can keep the water. And then what happens? Automatically, large particles would settle down at the bottom of the tank. Large particles, now if you have large particles in this water, maybe in the wastewater, these particles they are getting settled down at the bottom of the tank. So see, you can see sludge. You call that sludge zone. So settled down in, water is coming and then water is getting there, settling zone, and these are the sludge. So the particles are getting settled down at the bottom, at the bottom. So we can remove the sludge like this. So from the bottom, we can remove the sludge. So this is how sedimentation works. So this is a very common, very normal day-to-day example, coffee. And this one is maybe in a large organization, we can use this. And the next method is filtration. Filtration means, basically, you know what you mean by filter. Removal of particles from wastewater. This is how it happens. See, basically, we are using a very simple filter like this. Or else, think about a sink at your home or in an organization, even at the university, in cafeterias. They are having simply like this, or maybe something plastic they are putting inside the sink. When you are washing your hand after eating, all these food remains get collected here. They are not getting added to the sink, right? Lines, water lines. So when you are washing your hands with the water, these particles are getting separated, and that is called the filtration. And think about a filter, you can see there are several layers like this. So when the water is going through these lines, these layers, different layers are there, water is getting cleaned because particles are getting settled down in different layers. Here the particles are getting settled down, getting settled or getting filtered in this one, right? So this is basic filtration. And then oil and grease removal, there's a small video clip. I'm not going to show it now. Maybe we can watch this in the physical lecture. Oil and grease removal. Again, in the wastewater, there can be grease and there can be oil mixed in the wastewater. There are different methods where we can use to remove this oil and grease from the wastewater. Next one, biological treatment. Biologically also we can treat the water, we can treat the wastewater. So this is performed to lower the organic load, of dissolved organic compounds. Now in the wastewater, there can be different organics mixed in the wastewater. So this purification is to lower that organic load. There can be microorganisms. See, there can be microorganisms, mainly bacteria, do the decomposition of these compounds. Basically, in this biological process, to lower the organic load mix in the wastewater, we are using microorganisms. That means we are using bacteria to do the decomposition of these compounds. So that is what we do using microorganisms. There are two main categories of biological treatment: aerobic treatment and anaerobic treatment. What do you mean by aerobic treatment? Where bacteria utilize oxygen to degrade organic matters, generally quantified as BOD and other pollutants. Basically, we are using oxygen to do the biological treatment. Anaerobic means this process is carried out in the absence of the air, in a closed environment. We are not using air or the oxygen for this biological treatment. In the absence of air is used to treat high strength wastewater. So this is not done. Anaerobic treatments are not done outside because we are not mixing air. In the absence of air, we are using anaerobic treatments. Now, if I tell you one simple example, in the toilet pits, now in your at your home, in your organizations, in the university, there are toilet pits. In the toilet pits, when the sewage is getting collected to the toilet pits, it is a biological treatment. Naturally, biological treatment is happening with the bacteria, different bacteria. Now, at your home also, when it comes to your washroom, toilet pit is taken separately, and let's say you are taking a bath in the bathroom, and that wastewater with uh, what you are using shampoo, you are using conditioners and all, so your water is getting mixed with conditioner, shampoo. Basically these are chemicals. Remember, when you are removing that wastewater from the washroom, bathroom, that water is not getting mixed with your toilet pit. Because if you are adding that wastewater with uh, shampoo and conditioner and all these chemicals, that biological treatment in the toilet pit won't happen. Because in order to create an environment friendly for active bacteria activation, chemicals can't be there. So in that case, we need to separate toilet pit waste, water going to the toilet pit, as well as the bathroom waste, other bathroom waste water with chemicals. Remember those things. Because in order to have active bacteria activation, you can't keep your chemicals in there, right? So that is biological treatment. So this is like, when you can see this picture, if I say this is biological treatment happening incident, is this aerobic or anaerobic? Definitely this should be aerobic because we are using air. This is not in a closed environment, right? And then the chemical water purification, that means basically we are using different chemicals to purify the waste water. Different chemicals. So in this wastewater purification, different chemicals are put. And then coming under chemical water purification, pH adjustment is one method. You are changing the pH value of water, so using chemicals. So in that case, water is getting purified. That is one method, pH. And then, of course, reverse osmosis. What do you mean by reverse osmosis? Have you heard about RO plants? Mainly in Anuradhapura, Polonnaruwa areas, having different water issues, clean water issues. We different organizations and government has put up RO plants to clean the water. RO plants are expensive and they are using technology because that involves dissolving salt and minerals from the water. It's a complex process. So that is why RO plants are expensive, right? So that is the RO plant. That is also one chemical used water purification method. Actually, I have given some examples. At Jetwin Yala, they are using seawater for their consumption, and they are using seawater after RO plant treatments. They are using that water. And then also Procter and Gamble, P&G, that company, when they are manufacturing medicines and all, in order to get the most clean water for their medical manufacturing purposes, they are using these RO plants. So remember some examples. And then different advanced treatments, maybe activated carbon, removal of organic compounds. See this example. If this is the wastewater, when you are putting activated carbon, see what happens to the water? Purifying water by activated carbon. So that this wastewater has been purified now because of this activated carbon, right? And then air stripping. Air stripping means you are uh, removing ammonia, nitrogen, and some volatile organics from the wastewater. You are just stripping the water to the air, and then with different with different combinations of air, you are cleaning the water. There can be different maybe scientific things happening. I'm not explaining the scientific background of this air stripping, right? When you are putting water to the air, those things can reactions can happen, and then water is getting cleaned, right? And this is the Hotel Kandalama air purification system. See, ජලය පාවිච්චයට ගන්න අවස්ථා, instances where they use water. And then මේද රඳවනය, රඳනය. මේද රඳනය means, as you can see, the රඳනය, it's a filtration method. They are using a filter to filter the oil, maybe. And then අප ජල එකතු කිරීමේ ටැංකිය, they are collecting that waste water. කෘතිම ඔක්සිකරණය, see, aerobic methods. පෙරණ ලද ජල ටැංකිය, so the filtered water. And then they are using chlorine. සහිත පිරිසිදු කළ ජල ටැංකිය. Chlorine, using chlorine means it's a chemical purification. Especially when it comes to changing the pH value, you can put chlorine, right? ඝන අපද්‍රව්‍ය වියලා පොහොර කිරීම. What do you mean by ඝන අපද්‍රව්‍ය? Now here the sludge. When they can use sedimentation as one process, because you can keep water still in a stored in a tank, and after some time the large particles getting settled down at the bottom of the tank. That is the sludge. You can use that for use that as maybe fertilizers, right? Likewise, they have showed the process because they are actually using this process, Hotel Kandalama. And then Jetwin Blue, as you can see, these wastewater stored in tanks like this, large particles are sedimented at the bottom of the tanks. Sedimentation. And see, this is filtration. Wastewater is coming like this. These large particles are getting collected in this filter. Chetwynd Lighthouse, another sedimentation process. And all these photographs have been taken by Nuance and his team when they were on different field visits. So as you can see Nuance as well. So he has gone with the students like you when he was offering this course long time back with teams to actually see these different methods. So Chetwynd Lighthouse also, they have gone and watched the process, and whatever the plantation here, sludge has been collected here. This is the sludge maybe, right? What wastewater is getting removed, sludge is there after some time, right? And then we are moving to the accounting part of water footprint. Water footprint. So we basically, water volume consumed, evaporated or polluted per unit of time should be recorded. That is what the organizations need to do. Now the water footprint splits up into three main elements, but I have taken 4 here for your information. Mainly 3. There are 3 water footprints: blue, green, and gray. What do you mean by blue? Blue means volume of surface water and groundwater consumed during the production process. You call that blue water. Basically, surface water means rivers, right? Rivers, and then waterfalls can be there. And then the groundwater. So the volume of surface water and the groundwater you have consumed during the production process, we consider as blue water. Green water means volume of rainwater consumed during the production process. See, rainwater. volume of rainwater. And then what do you mean by gray water? Gray water means volume of wastewater generated in the process. So blue water means surface water and the groundwater. Green water means the volume of water coming from the rainwater. Gray water means the wastewater. What do you mean by black water? Black water, that is the fourth element. Volume of wastewater, it is type of gray water containing fecal matter and urine. Basically, uh, wastewater coming from the toilets. That is the black water. So these are the main three elements are blue, green, gray, and another element would be black. So as you can see, blue water, this is surface water, and groundwater is also there. Green water is the rainwater, rainfall. Gray water is the wastewater, basically polluted water. So in an organization, what happens in the production process, we can use blue water, and then we can use green water as the rainfall. Output would be gray water, basically gray water, polluted water. And if it includes fecal matters and urine, it can be black water. Right. Okay. Now think about a t-shirt like this. Think about a t-shirt like this. What do you think about the water consumption for this t-shirt? As per survey, it is 2,700 liters. So you might be wondering, t-shirt manufacturing is basically a dry process. How can 2,700 liters have been spent on producing one t-shirt like this? And look at these leather shoes. It says 16,600 liters involved in this manufacturing process. Again, how? Basically, when you are taking the water consumption of these two products, it's not only about the production process. When it comes to this t-shirt, this cotton t-shirt, it's all about the cotton farming. Cotton farming needs so much of water. So that's why we have to consider that in the supply chain, we have to think about the cotton farming as well. So when it comes to cotton farming, it needs so much of water. That's why we say to manufacture this t-shirt, we need 2,700 liters of water. What about these leather shoes? So the leather is manufactured, let's say, skin of cows and all. They are consuming water in their lifetime. So 16,600 liters would be there. So likewise, as you can see, there's a lot of water consumption when you are taking different products. We don't think about it much. So the disclosure requirements, like the other accounting techniques, the disclosure requirement for water would be GRI 303, Water and Effluents 2018 standard. Now there are different disclosure requirements. Now I think you guys are familiar with GRI now because we have talked about different GRIs up to now. Now here, disclosure 3031, interactions with water as a shared resource, management of water discharge related impacts. And then as you can see, there are three main segments we are talking about through the disclosures. Water withdrawal. How are we going to withdraw water for manufacturing purposes? What are the sources we are taking? Water withdrawal. Water discharge is what? Discharge means after using it, there's an output of water. So what is the water discharge at the end of the process? Consumption means what is the when you are manufacturing, when you are doing the manufacturing process, what is the consumption of water? So withdrawal, that is the input, consumption, that is the process, and then discharge is the output. Okay, these are the three main things. Before talking about these different elements, you need to know about this new concept, blue economy. What do you mean by blue economy? Actually, that is a subcategory of the green economy concept. You know, green economy concept being environmental friendly, talking about different environmental friendly products, environmental activities, and all. Green economy. Here, blue economy. That is basically related to water. Sustainable use of ocean, sea, and marine resources. That is the focus for economic growth or improved livelihoods and ocean ecosystem health. Basically, it talks about ocean, sea and marine resources. What is the aim of this new concept, blue economic concept? Go beyond traditional ocean-based economy by integrating conservation and sustainability. So it talks about conservation and sustainability when it comes to this blue economy. Key features are marine resource conservation. It talks about conserving marine resources. It can be fish, it can be plants related to the beach or ocean or sea areas, coastal resilience and tourism. That is also important because there's a tourism industry, especially in Sri Lanka, with regards to the beaches and all. Sustainable fisheries. We are doing fishing in a sustainable manner, and aquaculture. Ocean-based renewable energy, that is also possible. So these are the key features of blue economy. So this diagram is always all about renewable energy. Sustainable marine energy can play a vital role in social and economic development. And at the same time, we need to talk about fisheries. Marine fisheries contribute more than US dollars 270 billion annually to global GDP, right? And then more sustainable fisheries can generate more revenue, more fish, and help restore fish stocks. So it talks about fisheries. When you are doing the fishing activity, it should be sustainable. So that's why if you are talking about sustainable practices when it comes to fishing, fisheries can generate more revenue, on the other hand, economically, as well as it will generate more fish and then it help restore fish stocks. So it talks about sustainable fishing. And then what about maritime transport? Over 80% of the international goods traded are transported by sea, and the volume of seaborne trade is expected to double by 2030 and quadruple by 2050. That's why we have to be very careful and use sustainable methods when it comes to maritime transport. And then waste management. 80% of litter in the ocean is from land-based sources. That means land-based wastewater and everything is added to the sea. That is a very bad thing. So better waste management on land can help oceans recover. So these are the aspects covered in blue economy, as well as tourism. Ocean and coastal tourism can bring jobs, definitely, the tourism industry, and then economic growth. Coastal least developed countries and small island developing states receive more than 41 million visitors per year because of these oceans and all, and of course climate change. So these are the elements coming under blue economy. I'm not going to watch this video now. We can watch it later. Right, so I'm going back to the GRI. GRI Disclosure 303.1, Interactions with Water and Shared Resources. Here, the organization shall report a description of how the organization interacts with water, including how and where water is withdrawn, how the organization has taken the water, what are the sources, how the organization has consumed water, for which purposes, and then how the organization has discharged water, basically the output, and the water related impacts the organization has caused or contributed to. So that is the first one. And then 303 part 3, that is related to water withdrawal. The reporting organization shall report the following information: the total water withdrawal from all areas in megaliters. So see, you have to record with the volume in megaliters, and a breakdown of this total by the following sources. There should be a breakdown. What are the, if you have withdrawn water from surface water sources, maybe rivers, maybe waterfalls or anything, what you need to show the volume in megaliters. If you have taken groundwater, yes, you have to record. You have seawater, you have produced water or third party water. Likewise, in these categories, you need to mention the volume. Total water withdrawal from all areas with water stress in megaliters, and a breakdown of this total. A breakdown of total water withdrawal from each of the sources listed in disclosure. Likewise, you have to mention the source-wise water withdrawal. And then 3.303.4, that is related to water discharge. How are you going to discharge the water? Total water discharge to all areas again in megaliters, and a breakdown of this total by the following types of destination. From the surface water you have withdrawn, what is the discharge in megaliters? When it comes to groundwater, what is the discharge? When it comes to seawater, what is the discharge of seawater? Third party water and the volume of this total sent to use in their organization. And also a breakdown of total discharge to all areas in megaliters, right? All the areas, area wise you need to mention. Total water discharge to all areas with water stress in megaliters. There can be areas with water stress. If you have discharged water to those water stress areas, what is the volume? Likewise, you have to mention. Now, what do you mean by water stress? Now, you need to question that. What do you mean by water stress? Different stresses are there. Are you also stressed? So, what do you mean by water stress? Water stress occurs when the demand for water exceeds the available amount. Compared to the supply, compared to the available quantity, available amount of water, water demand is higher. Then that is the stress during a certain period or when poor quality restricts its use. Now, when it comes to this water stress, there are two aspects actually. Water stress causes deterioration of freshwater resources in terms of quantity. As a volume, water supply is not enough. And then quality wise is also water is not in good condition. Organic matter pollution. Likewise, there are different methods, different ways. The quality has dropped or the quantity has dropped. That is water stress. Now, as you can see, where water stress will be highest by 2050, based on this projection, as you can see, these dark brown color extremely high. These African countries, and then India, as you can see, India, these countries, water stress level is extremely high. Red color, high. Australia, likewise, these countries. And then medium to high, yellow color countries. If you can see, Sri Lanka is yellow color, medium to high. So we are in medium to high level. Low to medium, this is light blue. And then very low, that means low, these countries dark blue. So this is the water stress estimates. And then the third disclosure, 3035, that is related to water consumption. Water consumption is how the organization has consumed water. The total water consumption of all areas in megaliters, total water consumption from all areas with water stress, area-wise with the stress level, then what is the consumption? Changes in water storage in megaliters. If water storage has been identified as having a significant water-related impact, if you are storing water, changes to that water storage and NP. Any contextual information necessary to understand how the data have been compiled, such as any standards, methodologies, or assumptions used. So these are the disclosure requirements as per GRI 303. And then I have taken some examples from this Ceylon Coal Stores annual report, latest annual report. As you can see, water withdrawal and water consumption. So groundwater, from the groundwater, metric tons. This is the quantity. And then last year, this is the quantity. See, their water withdrawal and consumption has increased. And then that here the meaning is the total water withdrawal has become the consumption. They have used it. The total withdrawal has consumed. From the municipality water, then they have taken this much. Total water withdrawn, this much. And then total water consumption, this much. So they have taken in one table like this. Water intensity manufacturing, water intensity supermarkets. What is the intensity of water for manufacturing purposes as well as supermarkets, right? So water is the intensity has been shown separately for supermarkets, that is the green color line. Blue color line is manufacturing, right? Compared to the output, the use of water. As well as they have explained water discharge. Water discharge by destination. Municipality sewerage, and then drainage, and then recycled to rivers, lakes after being treated. What is the volume? Direct to rivers, lakes, wetlands, and marshes, ground through soakage pits provided to another organization. Likewise, they have explained. Total discharge of fresh water, non-water stress level, and total discharge of other water to non-water stress level. So they have different information types given in this Ceylon Cold Stores annual report. So with that, we are moving to the end of accounting for water uh, lecture part. So we'll be meeting you with the second recording that is related to other EMA tools. Thank you.